Right. So you're saying count or measure. Milk needed for a recipe. Yep, measure. Eggs needed for recipe. Tickets at a fair. Waist size. All right, write an equation. At work, you get paid $8.50 an hour. Your paycheck also includes a bonus of $50. So you can pick whatever two variables you want. I'm just going to use X and Y just to keep it, but whatever two variables you want. So what would it be if I use X and Y?
Y equals 8.5x plus 50.
Yeah, 850x plus 50. Yep. Good? All right, so we're doing discrete and continuous relations today. So your objective is students will be able to differentiate between discrete and continuous relations. Kira, you're good. If you want to bring your planner. Kira, if you want to bring your planner. All right, so the difference between continuous and discrete. So continuous is a graph with a line. And you do this when the situation allows for all values for the variable. Yes.
Is it always linear?
Not necessarily, no. So this is more just whether or not you're connecting the points of the line or not. Okay. And then discrete is a graph with only points. And then you use this when the situation only allows specific values for the variable and not all values. Bless you. So continuous is going to be your measure. And discrete is going to be your count. So you're kind of thinking about it as like, it's not necessarily whole numbers, but that's how it usually ends up. So if you're only able to really, like if only whole numbers make sense for what you're using, like number of tickets or number of pizzas or something, that's when it's going to be discrete because you're only going to have points at like the certain whole number values versus continuous where it's the line represents all the decimals and fractions and everything in between, okay? So first, we're just going to say discrete or continuous on the graphs. So if we look at the first graph, would this be discrete or continuous? Yep, continuous. And what about the second one? Yep, discrete. And then go ahead and do the next one. All right, which one is A going to be? Discrete. What about B? Yep. Okay, so when you're looking at these graphs, which one makes the most sense for count? Discrete or continuous? Discrete, right? Because it's points that you would count versus continuous you would measure, okay? So whenever we're doing these next ones with the variables and deciding if it's discrete or continuous, you want to think count or measure, like you did in the warm-up, okay? So rainfall last spring. So would I count or measure that? Yeah, you would measure it, so it would be continuous, okay? What about pizza sold? You'd count, so what would it be? Discrete, yep. All right, grade percent in this class, discrete or continuous? Continuous. Amount of juice left in a bottle? Continuous. Number of cars in a parking lot? Discrete because you'd count them, right? Is that measure? And then number of tickets sold for a game? Discrete. And temperature? Continuous, yep. And then go ahead and do the next ones. So discrete is when you would count. Continuous is if you would measure. So like here, number of cars in a parking lot, you'd count them. So you would use discrete. So it'd just be points instead of like a whole flowed line. No, it's more or less like if it's like a whole numbers only, or if it's like you could do like partial, like pieces. Yeah. All right, so what would coins in a stack be? Discrete. Area of a circle. Pearls on a necklace. A dog's weight. Distance ran in a race. Cartons of eggs sold. Discrete. Yep. Okay, we good there? Okay. So now the way we're going to apply this is we're going to use word problems that we're going to set up an equation for, graph them, and then you're going to use this to decide whether or not to connect your points on the line with a line at the end. Okay? All right, so the first one, continuous, continuous, discrete. All right, at a bowling alley, you prepay $5 per hour, and the machine shuts off when each hour is up. Write an equation and use it to graph the function. Assume you only want to go bowling for a maximum of 4 hours. So let's just use X and Y for all of them, just to make it easier. So we're going to write an equation, and we're going to make a table of values. So what would my equation be? Y equals what? 5x, yep, because it's $5 per hour. So this says you prepay $5 per hour, so you're buying whole hours at a time, prepaying, and then as soon as the hour's up, it shuts off. It's not going to like start charging you for partial of another hour, okay? What is the lowest amount of hours that I could bowl?
4.
Lowest.
1.
Do I have to go bowling? Does it say I have to go? No, I could go for 0, right? Just decide not to bowl. So 0. And then I would do 1 hour, 2 hours. Where am I going to stop? 4. Yep. So right here it says you only want to go bowling for a maximum of 4 hours. So you know on your table that we're going to stop at 4. Okay? All right, so if I go bowling for 0 hours, how much is it going to cost? 0? 1 hour? 2 hours? 3 hours? 4 hours? 20. Yep. Okay, so let's make a graph. right, so then plot your points. So 0, 0. Right in the corner. 1, 5. 2, 10. 3, 15. 4, 20. All right, so then we're going to look and try to find some information that tells us whether or not this is going to be discrete or continuous. So we're trying to figure out if I am only able to purchase whole hours or if I could do all the in-betweens. Like if I could bowl and pay for like 1 hour and 27 minutes, okay? So what information tells us like anything like that? Yep, good. So you're prepaying $5 per hour. So you have to buy the whole hour before you start, right? And then also the machine shuts off when each hour is up. So I'm only able to buy whole hours here. So is this going to be discrete or continuous? Discrete, yep. So do not connect. So there's going to be no line connecting these dots, okay? And when you're ready, go ahead and move on to the next one. Heather, are you paying attention? All right, let's go with this. All right, you work a part-time job over the summer and get paid $10 per hour. You can only work a maximum of 8 hours per day. Graph what your wages for one day could look like. So, I'm going to use X and Y again. So what would my equation be? Y equals what? Yep, 10x. So what is the least amount that I could work? Least. 0. And what's the most? 8. Yep, so 1, 2, 3, 4, 5, 6, 7. And the maximum is 8. Because it says you can only work a maximum of 8 hours per day. All right, so if I work 0 hours, how much am I getting paid? 1 hour? 2? Yeah, and then I'm just going to do my zeros. 40, 50, 60, 70, 80. Fun. Number of hours. I'm going to do like wages. Anything like that, like pay, wages, something like that, you just can't put like cost because that doesn't make sense. Okay. Okay, and then okay. Let's plot points. Here, here. This is hard. All right. So now, I know we don't necessarily know a whole lot about how jobs work, but if you go to work, you are able, so you clock in and you clock out whenever you're done. You're not only working whole hours and clocking out on the dot, like after the whole hour's up, okay? So if you work 2.5 hours, you're gonna get paid for 2.5 hours, you're gonna pay $25. Does that make sense? You're not only gonna get paid for whole hours. So would this be discrete or continuous? Continuous, yeah, because you can work anywhere from 0 to 8 hours and get paid for it. So this is gonna be continuous. So you would connect, because it's anything between one and the other. Not because you can work more, but you can work like partial hours, like the in-betweens, not just whole hours. So you could work like 2 hours and 24 minutes or whatever, so like the not just whole number hours. Does that make sense? Okay, so now the other thing we have to talk about too is whether or not you'd use narrow. So would I use narrow at this, on this? No, why? Yep, perfect, so no arrow. So because you have a max of 8 hours. So you can't go past that. Got it? Yeah. So you're usually looking at your x variable, and you're trying to see in the problem if it's like any information telling you that you can only do whole numbers, or if like it can be anything in between. So on the bowling one, it said that like you prepaid $5 per hour. So it's like you buy a whole hour right then, no matter what, no matter how much of it that you bowl, you have to buy the whole hour at once. Versus this one, where you're just going to work and you can work anything between 0 and 8 hours. Does that kind of make sense? It gets easier as you do it. Yeah. All right. So let's do this next one. You are filling a 10-gallon bucket with water. You already filled it with 4 gallons before pausing, and it fills at a rate of 2 gallons per minute. Graph the amount of time it will take to fill the bucket. All right. All right, so equation. Y equals, so what's the rate, like how that I'm filling it at? Yep, 2 gallons per minute, so 2x, and then how much do I already have? 4, so plus 4. So 2 gallons per minute plus the 4 gallons you already have in the bucket. Okay? All right. So our 4 is going to be where we're going to start. We start with 4 gallons at 0 minutes. That's our starting, right? So after 1 minute, how many gallons? 6. 2 minutes? How do I know when to stop? Yep, once I get to 10. So it's a 10-gallon bucket. So once I get to 10 gallons, then I stop. So at 3 minutes, how many? 10. Yep. So that means stop right there. All right, so let's make a graph. This is number of minutes. This is number of gallons. All right, so at 0, I'm already at 4 gallons right here. At 1, I go up to 6. At 2, I go up to 8. And at 3, I'm at 10. All right, so let's look number of minutes. And just if you think about the situation, would this be discrete or continuous? Continuous, yeah, because it's like time is always flowing, right? It's not like just jumping ahead and dropping whole gallons in at once. It's like a continuous flow of water, okay? It's continuous. And then arrow or no arrow? No arrow, why? Yeah, maximum has a maximum in it, so you're going to have an overflow. So anytime the problem mentions some sort of maximum, you won't put an arrow. Yeah.
I guess what I mean is, would it be y equal to 10 or y is less than or equal to 10?
Y is less than or equal to 10 is good. Yeah. All right, go ahead and do the last one on the last page. All right, we're going to just start just for the sake of time, okay? All right, you are saving money to To buy a new PlayStation, which costs $500, you earn $20 for every dog you walk, and you already have $340 saved. You're going to stop walking dogs as soon as you have enough money saved. So that last sentence right there, you are going to stop walking dogs as soon as you have enough money saved, that tells you have a maximum, okay? That you're not going to keep going. So here, x and y. So my equation is y equals what? Yep, 20x plus 340, because you already have the 340 saved. And then $20 per dog. Okay. So if I walk 0 dogs, how much money am I going to have? 340. 1 dog. And when am I stopping? When I get to 500. Yep. 2 dogs. 80. 3 dogs. 4 dogs. 5 dogs. 6 dogs. 7 dogs. And 8 dogs. 500. And that's our stopping. The number of dogs. And then money saved. This one's kind of a little difficult to grab. All right, so at 0, you're already up at 340 right here. 1 is going to be 360. 2 is at 380. 3 is at 400. Can I grab all the points? Yeah. Okay, so now, number of dogs. So think about it. Am I going to go on partial walks or walk partial dogs? Or only like whole walks with whole dogs? Whole walks, right? Like full walks. So is this continuous or discrete? Discrete, yeah. Because these are my only options. I'm not going to say, oh, I walked 4.5 dogs and made, it's just not going to, no. It's like just those are the options, okay? Make sense? Cool. All right, we're going to skip the lesson check for this one. You guys are done. Bye, guys. Have a good one.